Tullomer filament, as they claim, stronger than steel. Is it? Well, actually it is in one property, but I think it is time to give it a test. Hello, welcome back to my tech farm. Finally, Tullomer is here, the most wanted filament so far, and I got so many requests when will I test this filament. I mean, their marketing is good, stronger than steel, and they appear on some very popular YouTube channels. And I got not only the spool, but also I have some test objects printed by two different companies. It was not an easy journey. Let me show you how I got these materials. I forgot to mention that I'm not paid to do this video. Yes, this filament costs $500 per kilogram, so maybe it sounds like a sponsored video, but basically I will just do my regular testing methods and present you the results. I collected everything in a timeline. Everything started in November 2024 when the first video was created, and since that I started getting requests every 2 days when will I test Tullomer filament. I sent a message to the Z-Polymers, but no answer for 2 weeks. I contacted the Dynamism, the reseller, and asked them for the cooperation, but they told me they received the Z-Polymers. And in the meantime I started receiving donations to buy the filament, but no EU seller so far. And also I wrote to my patrons that I don't need extra donations. I will test the filament. Only question is if the company will send it to me or I will buy it myself. In December, finally after the Formnext, I got a reply from the Z-Polymers. We had an online meeting and they told me that first they want to print my test objects. And in the meantime, constant pressure by my viewers when will I test Tullomer filaments. So after 3 weeks, I contacted again the Dynamism to see if buying and custom shipping to EU is possible. The same day, the Sinpratex company from Germany offered to me that they will print the test objects if I will cover the material fees of approximately 67 euros, which I did. And next day, the Z-Polymers informed me that they will send me the filaments and the printed test objects too. And now we are in January. I received the objects from the Sinpratex and some footages, instructions, their experience. And 1 week later, I received the Tullomer filament with the objects printed by the Z-Polymers. And here we are now. So I downloaded the X1C profile. This is some experience by Sinpratex. The first layer inspection and flow dynamics should be off, no AMS. The filament is recommended to be dried. And the printing warps, and they didn't have any kind of success with group printing, only one by one. From the Z-Polymers informations, I got the profiles for the X1C and X1E, but also they are available on their website. And also they printed the test objects one by one. Some specifications from the website. They claim it is stronger than steel, and they have the animation where they tested the tensile strength of 50 micrometer Tullomer fiber and compared to the stainless steel, and yes, it was stronger, but my question is, how strong are still the printed objects? And some suggestions, the printing should be fast, small layer height, bed adhesive is required. Actually, fibers will be created during the printing. This is some footage from the Sinpratex. This means I have the test objects printed by two different companies, but also I will follow this profile and print my own objects too. Let's take a closer look of the test objects. So these 4 bags are printed by the Sinpratex company, and these are failed prints too. Only in first attempt, when they printed one by one, they have some successful printings too. Now the packaging is quite good, but even now I can see that, for example, this one test object which was printed in the vertical position is broken. And these 2 bags are printed by the Z-Polymers, this one using their old profile and this one with the new profile. But even here I can see some broken test objects. The packaging was fine, so only by bouncing against each other they broke. This one for the layer adhesion and this one which was printed in vertical position for the torque or twist test. So this is not too promising. I think we will have a weak layer adhesion here. I noticed on this one test objects printed by the Sinpratex company a little bit bigger warping, but the warping is quite strange. Usually the corners lifts up, but here the center part is higher. The object printed by the Z-Polymers is straight. In Europe, the max bed temperature of X1C is 110 degrees Celsius versus 120 in US. Maybe this is important and this makes this difference, because you will see my test object will be very similar to this one. I also measured if we have some shrinking of the printed objects, and actually they are bigger a little bit. I'm measuring above the elephant foot, 80.20. The design is 80 millimeters. This was printed by the Sinpratex, and let's see this one, printed by the Z-Polymers. This one is even bigger, 80.51 millimeters. And now let's see the spool. This is good packaging, and don't forget to cut it above the ceiling line. Okay, we have a sticker and nothing else. Not too much information on the sticker, but I believe that they will improve the packaging by time. The filament itself is not brittle and is quite strong for the bending, definitely. I don't have information about the drying, but I will just place it in a filament dryer 70 degrees Celsius 4 hours. Okay, filament is inserted and extruded on the other side. I've used the engineering plate with this glue stick on it. Officially they recommend using the Magico PC, but I don't have that material. I imported a profile for the X1 carbon, which was prepared by the Z-Polymers. 0.05 mm is the layer height. And the objects will be printed one by one. That's why we need some distance, so the nozzle will not hit the previously printed objects. And here you can see the first object and then the second one. I set the bed temperature to 90 degrees Celsius and I will wait a little bit so the chamber will be preheated. The start looks good and they will be printed one by one. As you can see, printing is at quite high speed. This definitely looks okay so far. Bed adhesion check. But it looks okay where the glue is placed. It looks completely okay. The adhesion is great, so the glue works fine. I will continue with printing in groups of 2 objects. And first time I can see some warping on my test object, and it is interesting that I mentioned earlier, the middle part lifted up, not the corners. This is terrifyingly fast. This one looks exactly like object printed by the Sinpratex company, with that warping in the middle. Bending test object, and this one is straight. Horizontal and now vertically printed objects for the torque or twist test. Unfortunately it's not finished because it removed from the bed, just to show you the weak layer adhesion. Okay. Horizontal and vertical objects for the shear test. I have to be very gentle with this one. Delamination. Vertical test objects for the layer adhesion test. It curls up and the nozzle hit the object. But at least I have enough material, so this is measurable. Looks like these new supports works, and also I'm printing on 300 degrees Celsius. And just for reference, I'm printing this hook, which should be strong in X and Y direction. And later I will compare this hook to the PET GF glass fiber reinforced PET, and I have my test objects prepared too, and I can start the mechanical testing. So I have here 4 groups of test objects printed by Z-Polymers old profile, Z-Polymers new profile, Sinpratex, and printed by me. A Benchy. I cut bottom 2 layers so it will start with a flat surface for better bed adhesion, and this will be more than 2 hours of printing because of that smaller layer height. I'm extremely curious if this Benchy will be finished and this purge line stick to the brim, but it will just help with the bed adhesion. Looking good so far, but the critical part will be in the second half, and as in the good old days, a 2-hour Benchy. Of course this one because of smaller layer height. 20 minutes more and I hope it will finish the bridging correctly. Wow, I never saw this kind of failure. I have to stop the printing. I wanted to start the video with presenting the most expensive Benchy I printed so far, but it's only a cabriolet Benchy. It delaminated here on the thin parts and it broke here. Interesting to see these fibers. I hope they are visible on the camera, and I think it has one big advantage. I think it will float, because if you are not familiar, the Benchy will sink. And let's see the Tullomer Cabriolet. Oh, the density is quite big. Okay, so I don't have this advantage. Sorry. From regular material it would float, so the density is quite big of this material. Or maybe I can just mention that I printed the most expensive Cabriolet Benchy. Some predictions what can we expect on a shear test. That was a really hard cutting. Even in this video I'm starting the experimenting with the creep test, and this is in reality too because it's the longest. Wow. Visually almost no deformation, except on this one, Z-Polymers new profile. I like better the old one. Just quickly to show you how an ABS looks like. This is a deformation in that case. Looks like in X and Y direction, this is very strong filament. This test makes no sense, because even after 3 days I cannot measure any changes on them, just a 0.02 mm up and down, that's the inaccuracy in the measuring. So instead I have a better test for these test objects. I will use this one, looks the strongest here. But I will remove all loads. Let's compare this test object with the 3D printed stainless steel. This is only 2 mm thick versus 5 mm of Tullomer. And the load will be 5 kilograms. I already measured it, 0.9 mm additional deformation. And now 3D printed stainless steel. 0.4 mm additional deformation. Even if it is not stronger than steel, this is incredibly good for 3D printed plastic, but let me show you how regular ABS looks like under 5 kg load. It's a good start, but let's continue with the testing. The torque or twist test and these test objects are printed in a horizontal position. .7 the peak. Similar results I got with the rest test objects. Big average load at 90 degree rotation 0.6 Nm and the maximum 0.8. It just don't have a chance to be strong in this test because of that weaker layer adhesion. For the vertical test I have only one test object which is still in one piece. Even this one, when I was preparing it, it broke off. Below 0.3 Nm, that is the minimum for this torque meter. For the feeling, I don't know, I think let's say 0.1 Nm. The impact test, I think there is a chance that it will not break under this half kilogram hammer. Let's see the first test object. Close enough. This is a second test object in slow motion. I still want to get some measurable numbers, and with this machine I can measure higher impacts. The zero position. The same break in slow motion. I have one more test object. We have similar breaks. These two were in my DIY machine and these two in this industrial impact tester. And they are theoretically tough materials, but I think we have that leaf spring effect, you know, because of that weaker layer adhesion. The hook test, and I'm starting with the glass fiber reinforced PET filament. And now the Tullomer. Tullomer could be very strong in this test if it would have better adhesion between the walls. 3-point bending test, and I'm placing these loads one by one, and I'm measuring the deformation in millimeters after 1, 30 and 60 seconds. This is speed up timeless video, but after this I will show you the numbers. These are very stiff materials, and more or less I got very similar results, except with this one. This was printed with the Sinpratex and it was stiffer. And only this one had this small warping, and I forgot that it warps in different direction. Usually I place them in this tester exactly in the position as they are printed, but this one was upside down because of this an interesting behavior of this filament. But I will just calculate the average value, and that goes to that summary table for my pattern supporters. The tensile test with objects printed in horizontal position. On the left side you can compare these numbers between each other, but what is important, the big average from these 8 test objects, and that number will be added to that summary table for my pattern supporters. Very strange failure. Instead of the break on a smallest cross-section area, it has some delamination and it slipped out from the holders. And now the layer adhesion test with vertically printed test objects. The big average is 3 kilograms, which is below acceptable. And why is this important even for those objects which will be loaded in X and Y direction only? I explain in the conclusions part. I need one more test. I reprinted these vertical test objects on the Qidi X-Max 3 on 340 degrees Celsius and 60 degrees Celsius actively heated chamber. 9.9 kilograms. This is significant improvement, but this is still weak. With this size of the test objects, the break load should be about 20 kilograms. Shear test with horizontally printed test objects, and in all 4 cases I was not able to break it with my equipment. This is how they looks like after this attempt. These fibers really resist great to this shear stress, and I can see even it started with a delamination, but it is extremely strong in this test. And these are printed in vertical position where the layer adhesion is important. The temperature test in the oven, where I want to record the temperature of the first deformation. And this part will be extremely speeded up because it would be boring. Nothing happened until 212 degrees Celsius where I stopped the experiment. And I just want to check the hardness, so typical knocking test. I really have mixed feelings about this filament. On one side they created something new, very unique, extremely strong in X and Y direction, until that weakness of the layer and wall adhesion is not involved. This means we need very specific applications for this filament. But I believe it would be much stronger if it would have good layer adhesion. For example, in my hook test, it is strong even now, but it could be much better if it would have a good wall adhesion. Or in my impact test, that object wouldn't even bend if it would have a good layer adhesion. Now there is a problem with the printing too. We need a good layer adhesion, especially with the materials which tends to warp. Because in this case, during the printing, nozzle will create some side force because of that friction, and then we need a good bed adhesion and layer adhesion to resist to this side force. And you saw typical example is that Benchy. It was almost finished, but at the end it curves up a little bit the material and just a small side force and it was broken, and actually it was a failed print. So I believe that some improvements are required here. I'm not sure how, because I tried even to print on higher temperatures. Maybe some kind of co-extrusion would be the solution. For example, inside is the Tullomer, outside is some other material. And I know that CNC Kitchen got the filament from the Tullomer, and I'm very curious about his videos. I think he can do the co-extrusion. I've given him some suggestions about this. And if you have some other experience, then I know, write me a few lines in the comment section. Thank you for watching and happy printing.